and information. What is it in Fabrika? We have a reality dimension. This reality coming there, Miley. Basically, what it has, we have empty. We call it. It is very like layman word, but we are gonna call it that. We have empty Fabrika. Empty Fabrika is the individual Fabrika which has no connection to any other Fabrika. It is individual and it's alone. So therefore, what will happen? This doesn't have any wave function, does not have any kind of wave function. Therefore, it doesn't have any kind of information associated with it. If we quantize space-time and reality, we call it STR from now, space-time and reality, and because it doesn't have any wave function, therefore, you can completely remove it from existence. Or it can create the other one. Because information, there is no information associated with it, therefore it can get destroyed. Or it can actually get recreated.
But one can put information like in here?
No. It should be a Barber system. So minimum, let's say 2. Minimum 2. Okay? Let's say 2 Planck size.
2 Barber.
Yes. Minimum.
Fabrikas can
create the first information. Okay? And then we can actually have more and in different shapes. And each shape represents certain kind of field. We call it Barber system again because we believe that time governing the Barber system. Field is governed by time. So basically we can have another one here, and then another one, and then basically, and then a bigger Barber system. Like exactly, it's getting bigger and bigger, creating individual and also merged realities at the same time. And this is information. This is information. This is information. This is information. These are basically, each system will have its own information. But individual Fabrika doesn't have any information, and therefore we can destroy it. It's just the information minimum bit. Like for example, you say that 0, it has any information? No. But when you combine it as 0 and 1, when you define a framework like that, it will contain the information.
But universe has a lot of Fabrikas which are not the Barbers. Yeah, they are.
Exactly. That's why gravity can actually only destroy Fabrikas. We never said gravity will destroy the Barber systems. We said gravity will eat up Fabrikas. We never said it will eat up the Barber systems. So gravity doesn't affect the field in a way that it affects space and time.
So just gravity can destroy Fabrikas.
Exactly.
Otherwise Fabrikas stay forever.
Yes, and get multiplied.
Or multiplied.
Yes.
They should be defined exactly. What
the constant
can Fabrika destruct itself, or other Fabrika can destruct other Fabrika?
Exactly. No, they cannot destroy the others. They can actually get multiplied. The only visible or understandable thing that it can destroy Fabrikas is the Barber system called mass. So basically, when we have mass, that Barber system is eating up Fabrikas all the time. That's called gravity.
When we say space-time reality, for each Fabrika,
yes,
X, Y, Z, these are coordinates in our system, right?
Yes.
This Fabrika is real, this Fabrika is real.
Exactly.
This X, Y, Z is what we assign to each Fabrika, yeah?
Exactly.
In some system, in
yes.
some inertial system.
Yes. And then what can happen, the most important part is this, is basically when we create a Barber system, this Barber system starts to represent one time, one place, Remember, one time and one place. So it doesn't contain a lot of fabrikas, each one representing each time, like a time and a space. No, this will represent one time and one space.
So to be translated, if there were two fabrikas and they create
They will be one space from
for
that
me,
moment.
this will be they
One
have
system.
one coordinate.
Yes, and also reality
In my
dimension.
system, they will have one coordinate, even 100 fabrikas.
Yes, they will have one coordinate, and that's how the wave function in quantum physics works.
So-
That's why we see one particle in several places.
So all of them will have the same XYZ.
Yes,
XYZ in time.
exactly. That is Tbilisi interpretation of quantum physics. It means we have one particle. It seems to us it's everywhere in that
Yeah,
wave
it seems
system.
like it's like that.
But it's not everywhere. That everywhere is one where. It is just one place,
Maybe-
but it got bigger.
At the beginning they were like that, but because of Barbas they kind of collapse in one
Yes.
point.
When the Barber system collapsed,
Relative to me,
Yes.
they collapse in one point.
exactly,
Or
exactly. That is relative to you. When we collapse the Barber system, they end up, that basically arrangement of the space-time will be again normalized without wave, and therefore the particle will end up somewhere. Now, this Barber system will collapse when you observe it by forcing R, or it will collapse when you basically force XYZ. It means you have a wall, you force XYZ to
this
it.
is also measurement.
Yes.
If you say that I measure here.
Yes, when you have a wall, it will be measured. So basically, you are enforcing X, Y, Z, and then you are enforcing reality dimension. You will make it collapse. One of the predictions of this theory, if you somehow you can enforce T also, you can enforce the time to this Barber system, it will collapse. Now we can think about the problem, like how we can enforce the time to that and make it collapse. We can think about it. Maybe we can actually even think about that quantum eraser.
You also kind of you measure at some point, yeah. You enforce time also. When you
I think it is very related to the quantum eraser time problem.
when you use your eraser does a job, that is a fixing of time.
Yes, it's fixing the time,
But
and
actually,
that's why this will collapse.
But actually, we are not switching here. It's on all the time. Actually, this device is on all the time, and at some point we just let the photons come in. But eraser is on the time.
Yes, but still, what we observe is that we change the past. This is what we observe. But our observation is based on understanding that the whole Barber system has a different time. But in one Barber system, we have same clock here and here and here in the place that we see. It's the same place, same time, and same basically reality.
Before that is before measurement. That's important. When you say Barber has
Yes.
the same space,
When you measure it, you collapse it.
it's later.
It's already collapsed.
Even before measurement, same space. You mean that the one there are 100, let's say 100 fabrikas like that.
Yes.
They build the
Barber system, and it's
What
the
is
same
the same?
system.
It is for me. It's one is here, one is here. How is the same? This is-
No. What you see, what you feel, it is they are everywhere. But that is not everywhere. The whole Barber system is one place.
So my coordinates are different.
Yes,
So when I say
than the reality.
-7, this is x is plus 15. That's a different x, y, z. So
Exactly. That's why you feel this particle was everywhere, but it's not everywhere.
So my device is here, and I say that is different than there. How that knows? what
That is
the
your
person-
observation. But actually, that subspace that created Barber system is one place only.
It's not visible. This x, y, z. What you write? Is this actually not visible x, y, z? My visible x, y, z is
Okay.
there, yeah.
Again, I'm gonna go through this very important.
Yeah.
Basically-
Barber same space. What?
It's subspace.
I cannot see it in subspace, right?
You can see it. What you feel is
I
a
see.
different than reality. Like I will tell you. Okay.
Yeah, I see my devices, one is here, one is here.
Okay.
Yeah, I see that they are not together.
Yes.
So it could be some.
No. I will. Again, this is extremely important because we want to make
Yeah,
sure we're on
same
the
space.
same
What
page.
does it mean? It's important two words. Same
Yes.
space, same time.
Yeah.
Same coordinate.
Yes.
That's important notion.
Okay, it's very, very important. This is the main understanding of the same space in the wave function in the whole quantum physics and tableau interpretation. In a normal space without wave, what we have a coordinate system. For example, you say the particle, for example, one particle is located here. Okay? And I say it's D2, let's say. Okay?
Maybe here.
Yeah.
Yeah.
Let's say we create a wave. Okay. Now, I have particle in this space. It's like okay. Let's see. Okay, let's see. These fabricas get connected to each other and they create a subspace. And my particle is here, and here, and here, and here, and here, and here. But it's very important. That is a different thing with Copenhagen interpretation and Tableau interpretation. In our interpretation, these places, from the time that they had the handshake, they all are same place. They are, for example, D2, D3, C3, 4C, they are all representing same place, one place, and one time, one place, space, one time, and one reality. They represent one thing till they are together. So the electron is not in several places. It is in one place. But what we see, we cannot see this Borba system. Therefore, and wave function, therefore, we cannot see. What we see the particle is everywhere. We feel it is everywhere. But what is the difference between Borba system and wave function in quantum field theory? It's extremely important. Time and reality. This is the main important thing. That's why quantum eraser has a question now. Because in this system, we are representing same time and same place and same space and same reality. This doesn't mean the time here and here, it seems that the time here and here and here, it's the same place. It's exactly functions as the same thing. That's how, basically, when we measure in a quantum eraser experiment, we will have a different understanding as observer as a time toward this. For this, it's the same time. The space, it doesn't matter how far it is, like the second detector, how far it is, the space is similar. Here and here is similar for that particle. Because this particle, it is in one space as its own observation. So therefore, this is exactly what will happen also in quantum entanglement. They are still in the same place, but we took, for example, we address this and this at the same reality, same space, and same time, F1, and for example, A6 is the same reality. They are far away, but they act together. That's why when we collapse the reality here, it will collapse here as well.
Even they are at large distance, right?
Exactly. It seems to us, again, like observer, we feel like that because we just see this. We don't see the Borba system as it should be. That's why Copenhagen interpretation, they say the particle is everywhere, but integralistic interpretation will say, no, particle is in one place only. But that place, in the eyes of the observer, got way bigger. And it's creating even a wave function.
I think one would say that Z breaks the locality.
Absolutely. That is absolutely like breaks the locality as a definition in the general relativity. So this is a new definition of locality, because in locality you don't have this.
Distance doesn't matter. Here, distance could be very big.
No, distance will be relative.
In our space.
We are defining a relative space. This is totally new concept. We are defining a relative space. For me, what I see is a wave function as observer is a wave function. This is what I feel and I see. But actually, for the particle.
It's a different space from my space. Yes, this is not that space, but this is.
This is that space of that particle. So the observer, for example, in entanglement, will see these two spaces in the two places of like two different places, but actually they are same place. That's why whatever you do here, it happens here, and it's not also breaking the transfer of information like with the light, because they don't have distance with each other unless we break it. And then if we affect the reality here, it will get affected here. So basically, whatever we do, if we observe it in different systems, it will have the effect here and there. So basically, it's very important. The Barber system is a handshake of Fabrikas, and it creates space-time reality. And for sure, like strings and matter and energy, everything comes from different handshake of Barber systems. So whatever we see in the universe, created by Fabrikas, and different handshakes of Fabrikas. Like whatever force we have, whatever like in a standard model, basically any kind of particles and forces that we have, everything is a different handshake of Fabrikas. In a string theory, again, if a string has a meaning, that string is a handshake of like Fabrikas. A certain handshake of Fabrikas. And then in that case you can actually define why they see it as a different dimension. It's not a different dimension. It's a subspace created in a very specific way. You know, this subspace works differently from what we observe as a normalized without wave space, flat space. It works totally differently. Time works differently. Space works differently. Reality works differently. Reality works as one unity.
Is it more, now I think, is it the right word for the subspace, or is it kind of parallel space?
To be honest, I think it's best to call it Barber. Why? Because we are defining totally something new. If you say subspace, why I'm hesitating to call this field? Because field has a background in quantum physics, governed by time. Always go at the time factor to this. But in subspace, also subspace has a previous definition in physics. We are defining a new space and time, totally new. A quantized space and time that basically the definition of locality is different than definition in the general relativity. The locality can be like this, representing one place only, not like whatever you refer. Like just imagine we have lights here, and then we switch the light. I touch D2, the whole thing will turn on. I touch D3, the whole thing will turn on. I touch, for example, I don't know, C5, the whole thing will turn on.
With the overspeed velocity, it could be.
Yes, like because it's the same place.
Same place. But here in our place, let's say Z point will never be the Z point. There is distance between them. So you cannot.
It is your observation. For that particle, it's different. That is how entanglement works. That is how entanglement works. You observe, you feel this is A6. But for the particle, F1 and A6, they are same place because they created a Barber system. They are same place, they are representing same place. And same time, that time is important, and same reality. Therefore, when you touch the reality here, this will change. That is the observation of the particle. Now, it can answer to the quantum eraser dilemma, for sure, because we have a Barber system in the quantum eraser, delay choice quantum eraser experiment, and that Barber system created in different space, you see, they measure the distance. Detector 1 and detector 2, detector 3, they have different distances. And that distance created a problem. It seems we are changing the past, or we are sending the information with more than speed of light, but that's not true. What will happen is that basically we created a Barber system, and that Barber system doesn't understand the distance as we see it. It's the same place. It's the same place.
To me appears that non-distance space, Barber space, that's the most mystical thing. It is not a part of this space. This is kind of parallel space.
Look, we can call it like wormholes in general relativity, but there is a problem. Wormhole in general relativity requires. Yes, what requires? It requires that you connect the whole space and time, like the space and time with 2 points together. So you should make the connection. Therefore, this wormhole cannot be a good answer to that, because then, again, time will be a big question here. In this, time is the same thing. Space is the same thing, and reality is the same thing.
One can say here that while you are in wormhole, time doesn't change.
Exactly. What we say is this: we say space and time and reality observation is relative.
So, relative to us, it is not.
Is different than relative to the particle itself.
So then it's not a. It could be some parallel space. Sometimes in string.
Okay, I agree with that word. Okay, parallel space, let's say.
Or some additional dimensions.
Look,
okay.
Yeah, we define it. Reality. We define the additional dimension.
A space with its size could be
also yes.
additional.
Yes, but you know,
maybe say E8 or other 4 dimensions are there.
Maybe, but what we should say that they never define reality as dimension. It's extremely important in this theory that we define reality as dimension. That E8 lattice, it can be a Barber system. Like can be a Barber system, and they are defining what they are defining. They are defining different type of handshakes in E8 as a different effect. Let's say you handshake like this, then a spin on, like a spin up, and then basically you have this charge, and then therefore you have this particle. So okay, that is not contradicting with what we say. We say Barber systems can have different shapes, and therefore create different matter and different energy and different forces. And different effects, totally different effects. So what we see in the universe, everything started with empty fabricas, and then when I started to handshake, from that point, they started to create different effects and different energies and different matters. And then got bigger and bigger, so the system created another system and then basically integrated with another Barber system and another Barber system. And the stability of Barber systems are very different. So basically, we are also a wave function. Like me as a human, I'm a wave function. I'm not a static like matter. I have a wave and I have a vibration, but I'm stable because that Barber system that is made me totally, it is stable.
Barber,
now,
so it should be also in theory defined very clearly. Barber system is kind of unity of fabricas, right?
Unity of fabricas, which
how matter is poured into this unity of fabricas. Yeah.
Matter is created by fabricas. Like okay, that is we are coming to E8 lattice. What they say exactly similar concept, but they don't have a definition of gravity exactly as far as I know. What they say is this. They say okay, like in the model that they have, they say okay. For example, if you connect this part, like they are also talking about Planck's, and this part it will create, for example, this type of quark. If you create, for example, this and this, with this spin and this charge, like with this spin and this model, like you connect 4 barbers, for example, 4 fabricas, here and here, we like just layman word just to basically decode. Then you create this type of force, for example, and then if you change it, then you will create another particle or another force.
So geometry tells you what particle you have, yeah?
Yes, and that is information, the whole matter, the
Information.
whole energy is information. And what is information is basically the connection of the fabricas. This is what we say.
We have to understand good information. Now, I don't know much about it, but it looks like it's a keystone of everything. Information,
Yeah.
reality, what Z creates, and Z creates matter, you say, Z reality can
Yes,
matter.
like fabricas, when they connect and handshake together, they start creating different type of particles or strings or let's say forces.
So our matter is not constant. It's not initial given, but it's dynamic.
Absolutely. That's how basically matter converts to
Oh, I
energy.
have it wrong. I wrote it, it's a constant.
No, we'll change this together, it's fine. So basically, matter is the definition of different handshakes of the Barbour systems.
That's what string says, string theory. That
Mhm.
if you have string, if it evaporates like that, then it gives one particle. If it evaporates like
Exactly.
that, it gives other particle.
This is totally
So,
matched with the string
dynamics
theory.
gives you particle.
Yes, this is matched with the string theory because what we say is the string itself is connection of fabricas. We go one level deeper. Why we say this? Because in the string theory there are a lot of like different type of theories connected together, and they want to define what is this string, and therefore this is the initial step of their theory. So the string is the initial step of the theory. What we say is fabrica will be the definition starting point because a string has information. Fabrica is the minimum place that doesn't contain information. Anything bigger than fabrica is information. Anything bigger. That's why we don't have anything less than Planck size.
Because maybe you have, if you have two fabricas, you have Z and
That is
Z.
information. Exactly.
0, 1.
As soon as there are more than one, they are information. There is information.
Information of how you build those two, like
Yes.
Z or like Z.
Exactly.
If you have 3 like Z, like Z,
Exactly.
like Z,
It is information. Like exactly this is what we say. And that's why it is underlaying, the Fabrica theory is underlaying of a string theory in quantum physics completely. We can call it even Fabrica physics. Why? Because we are defining the minimum information.
Yeah.
Planck did not do that. We are doing it. What we are doing, we are saying what is the minimum information? What is zero information? We define this. Zero information is the Fabrica itself. And therefore it can get destroyed by gravity. That part is matching somehow.
Information cannot be destroyed.
Information cannot get destroyed.
I don't know where it comes from, this sentence.
No,
I just
this is the basis of quantum
read
physics.
somewhere and don't know who invented
It is the basis of the quantum physics for sure. Because if you get this, if you destroy information, a lot of crises will happen in quantum physics. But anyway, what we should say is this: the minimum information means zero information. Is the empty fabrica,
Yeah.
known fabrica. Therefore, known fabrica can get destroyed. But if you become like, if you make it 2, if you want to destroy it, the information should transfer to another form, or like you should do something with that information. Like matter cannot get destroyed, or for example, matter and converting it to energy. How that happens? Like basically, the Barbour system will collapse, and we create a smaller Barbour systems, each one representing energy. That's how it works. And that's why we can define the whole system based on basically minimum information, which is 0 in the Planck size.
And we are talking still about the fabricas.
Fabricas, absolutely.
Because metal is different story, which is
No, we can-
massless, mass, photon, electron.
All of them, they are a Barbour system. Higgs field is a Barbour system. Why we say it Higgs field? Because it creates mass. It's interaction with other Barbour system.
Yeah.
It's interaction with other Barbour system. Speed and then time dilation is the interaction of the Barbour system matter with basically other fabricas. This is how basically time dilation happens. This is length contradiction happens. And they basically, everything that happens in general relativity, it is predictable by this theory.
So also,
At the same time with quantum physics.
what I have to say now, why do we need Z system as additional dimensions? Because in our 3 dimensions, people measure the maximum speed is speed of light. That's why if we say we need more than speed of light, then let's go to other 4 dimensions. So that that non-locality happens in other 4 dimensions. Because in our 4 dimensions,
they should not define it as another dimension. Because this is the same space, still, this is the same space, right?
People will say in our 4 dimensions, locality should be preserved. It cannot be that you do something and it goes with more than speed of light.
It's not going more than the speed of light because this is the same space. From here, for that particle, from here to here is 0.
Yeah, but how?
It's a subspace, it's the same space.
Before it was not 0. But once it becomes Barpa,
it becomes 0 because time is
this process.
a speed of
yes. How
a speed of like c. It is matter of t, correct?
Yes.
Now, what that means? This means the t
is changing on the way.
This is representation of same time for the particle. This whole system is representation of the same time. It's not representing, so from here to here, because it's the same space, the same time.
So if you go from here to here, you might lose 0 time. Yeah,
yes.
if it's 1 Barpa, yeah?
That's why the light, like, just imagine, the light, the photon doesn't feel time. Doesn't feel time because it's a wave function before you measure it. Light is a wave function before you measure it.
But still, photon needs moves with c velocity. Photon needs the time to come from here to here.
No, our observation is this.
We are.
Look, this is exactly what I'm saying. Our observation is this. Photon observation is different. Photon observation is just like I reach from this side of the universe to that side just in 0 seconds. That is observation.